Thank you for coming. Um, my name is Kishore Jalleda. I work as a senior director of production engineering. Production engineering, at Yahoo it's called production engineering, and it's similar to Google's SRE. I think at Facebook as well they call it production engineering. I run or lead several different production engineering teams at Yahoo. Most popular destinations, as you can imagine, yahoo.com, Yahoo News, Yahoo Finance, Yahoo Flurry, and also some back-end teams which power these user-facing properties. This is Gopal. Already he was mentioned. He will be a co-presenter. He will come in during the second half of the talk. He'll be focusing on resilience and how we have applied multiple layers of resilience to make sure that our user experience is seamless. Okay, so when we proposed the talk, our goal was simple. We wanted to give you guys insights into some of the technical, some of the work we've done to overcome some technical, cultural, and process barriers to help us launch redesigned versions of our sites at massive scale over the past year or so. As you can imagine, this has not been easy. Just as a raise of hands, how many people in this room like change? I mean, change like in general. Oh, you guys should be our customers. Okay. Unfortunately, our customers were not so, our users were not so kind on us. Again, this is a bit about Yahoo scale, but as you can imagine, when you are dealing with 1 billion users, the business challenges are immense when you're trying to, especially when you're trying to redesign something which is so close to people's hearts, which people use on a daily basis. It is part of their daily habits. So, to tell you a bit of a story, when the finance team was redesigning the website, I mean, I don't think we've done a redesign in close to 5 years or so. They literally had a hard time sleeping for a week going into the redesign. It was not because the team wasn't confident. It was because the team was anxious as to what and how the users would react to such a big redesign. And since the rollout in July this year, I think there's an estimated of about 75 million monthly active users who use Yahoo Finance. A majority of them sort of gave us a not so great reaction when we launched this. There was severe backlash from the users. In fact, there are some prominent people in the Valley. Bill Gurley is one of them. He's a VC. I think he invested in Uber. He's at least one of the early investors in Uber. He made this comment. So it's, as you can imagine, it's fairly scary when you hear comments like these, especially from prominent users who use these products on a daily basis to do their jobs. But we knew that the change was necessary to make the product better. We fundamentally believed in that. We wanted to make the product more modern, more in line with what other companies were doing, like Facebook, where you have infinite scroll and your stream and things like that. The team knew that there was no way in which we can make everyone happy. When you're redesigning something at scale, there's literally no way you can make everyone happy, or that we could just magically make all the complaints go away. But we knew that we would religiously hear to the feedback given by all our users and actually follow up on it, as you see on the screen. This was actually our product head responding to Bill Gurley's comments. Because one thing we always wanted was, we wanted to make sure that at least most of our users were getting, seamless experience, and they were as happy as possible with the redesigned versions of the site. One word of caution though, if you're a product manager, I'm not a product visionary by any means, but if you're a product person, product management is not for the faint of heart. You sort of have to have a thick skin especially when you're redesigning something at scale. But if you have the right fortitude, and if you listen to your customers, their feedback, and quickly go back and iterate on it, that normally helps. So, how do you validate something is good for your users? Make sure you run a ton of experiments. In fact, for about 18 months leading into the launch, there were several user feedback sessions that were conducted. Lots of feedback was taken, and of course, ton of experiments were run. In fact, at any given point of time, for any of our verticals, we have over 100 iterations or experiments running. So the chances are that almost every single of the billion users we have is part of an experiment. Validating metrics at this scale is not easy, because even if you're talking about a 0.1%, that's a million users. So make sure that you're making the right decisions for the user. The other thing is, because Yahoo is one single big network, we have the media sites. We also have search, we have mail, and we do send a significant amount of traffic from the media sites onto things like mail. So make sure you're not cannibalizing other services when you are redesigning these launches. Products. Okay. So that was the business challenges, right, of redesigning something at scale. But obviously there's engineering and operational challenges of doing such a major redesign. Now these become especially important when you are, again, trying to do something which for a fact is sort of going to piss a lot of people off. So, and the last thing you want is reliability issues, right? Or issues with your launch. Because that's not going to help anyone. So we had to take extra precaution and measures to make sure that the launches were seamless. And what we found helpful in the successful launches is what we call a sort of DevOps. I know DevOps is a loaded term, and we'll get into what that means at Yahoo. But we did use some of the best practices in launching these products. One thing before I go into more of DevOps is what we've also noticed is whenever you redesign something, there's this perception that the newer version is somehow slower than the older one. But we found that often that's not the case. It's just people perceive, maybe because they're already not too happy, but the fact that something they've been using on a daily basis has changed. Okay. I've seen, when I say the word DevOps, as I mentioned, it's a loaded term. I've seen all kinds of reactions, both good and bad. But to us, and I think most people seem to agree, at least the people I work with, I think DevOps is really about eliminating the technical process and cultural barriers that sit between idea and execution. In lean startup terms, I worked at IMU before. So, if you know about the lean startup principles, fundamentally it's really about minimizing the total time through your build, measure, learn loop, right? So sort of DevOps is a way to minimize the time between build, measure, and learn. Again, this is what we sort of came up with. To us, this is like the foundation. And again, DevOps, I don't think is a title. So if you feel DevOps is a title, talk to me after. I would be happy to convince you that DevOps is not a title. Okay. In any model or methodology, there's always three elements. There's people, process, and technology, right? For our purposes, let's call it culture, process, and tools. What do I mean by that? Culture, it's about behaviors, it's about incentives, it's about the feedback loops. Processes, there's several different kinds of processes. You have development processes like Agile, Scrum, code reviews, PRs. There's release processes like end-to-end, CD pipelines, pre-launch checklists. There's operations processes, like directed alerting. I'll get into that a little bit later. Postmortems and tools. Of course, there's so many that I can't even list out here. But what we have found when it comes to culture is to ask that question, like, what kind of a culture do you want? Like, what is this DevOps culture? So to us, it's about enabling a culture of ownership and excellence, right? And what do I mean by that? What do I mean by ownership? No barriers. The dev teams pretty much own the whole life cycle. I like to call it you wrote it, you own it. Investing in fixing the root causes as opposed to just scratching the surface. To us, that's ownership. And when I say excellence, I'm talking about the pride, both the product pride and the engineering pride, and also the pride in following some technical excellence best practices. Process. Make sure your engineering processes that are agile and automated. What do I mean by that? Design them to be fast, agile, obey no boundaries. What do I mean by agile? Of course, iterative, experimental. You're delivering something of value every so often. Learning, fast feedback cycles, right? Automated, what do I mean by that? Make sure you're doing you make the machines do the heavy lifting, because I have better things to do, right? Tools, develop tools which are self-serve and reusable. Make sure you're solving problems with software. Remember, if you go back to the definition of DevOps, I said, using software. I think the using software is critical. So make sure you're solving operability problems with software. Treat operations as an engineering discipline. The thing about tools is they also enable automated processes and ownership, right? And also, enable agile processes, and cultures of excellence. Some approaches we have taken to tools is, make sure they are self-serve. Again, it enables dev ownership once a tool is self-serve, and it goes hand in hand with tooling. Make sure they're usable. Make sure it's easy to use, and I think finally, make as much, leverage as much open source as possible. This is something we do a lot at Yahoo. All right. So if you look at DevOps as a function, we like to sort of say that it's, or look at it as though it's built on three different pillars, or three different functional pillars. First, we covered the how, and now we're covering the what of DevOps. First pillar is deliver. So make sure you're delivering products to market quickly. This is one of the key functions. Prevent defects from reaching customers, and repair production issues quickly. So those are sort of the three pillars of DevOps, at least the way we like to look at things. Let's look at deliver. Just clicking through the slides so that you can read through the different things. What do I mean by sustainable velocity? What I mean by that is sometimes slapdash is okay, like putting things together quickly, but most times what I mean by sustainable velocity is good coding practices, technical excellence, robust systems, robust platforms. And make sure there's a metric for measuring the velocity. For us, it's about time to market. Make sure you're also seeing how it's trending over time. And when I say spin up, it's not just the compute or capacity. It's really about the whole thing, like monitoring CD pipelines and everything else. Code with excellence, make sure there's pre-commit flows and dev tools. And also there's PR built on your pre-commit flows. A special mention about a compute platform. If you want to be DevOps, I highly recommend that you have a elastic, billable, on-demand compute platform. The reason this is important is because when something is billable, it actually encourages good behavior. It creates that culture of accountability and ownership. And self-serve is important because, again, on-demand self-serve is important because, again, it creates a culture of ownership. On prevent, again, I will click through it. I'm almost done here. There's goals and metrics. The thing to note here is, if you look at deliver, garbage in and garbage out, or garbage in is garbage out, right? So what I mean by that is, if you have a fast CD pipeline and you have, delivering crappy code, or you have elastic serving stacks to run crappy code, that's no good, right? So make sure you're tracking the metric that, in this case, it's quality, so the number of issues caught could be a metric, or the issues not caught, or even better, issues never existed in the first place. Also make sure there's CD gates. To us, the heart of CD, or continuous delivery, is a certification plan, and hopefully that's automated as well. And flawless launches, and make sure you're testing the proposition before game day, not after, so that you're actually ready for game day. Finally, repair. And by repair, I don't mean it's server fixes. What I really mean by that is, how do you take feedback from running applications quickly so that you minimize the time through the build, measure, learn loop. It's really about how dev teams use that user feedback to improve the quality of the product. I'd like to talk about a couple of tools that we have used here, which has helped us tremendously in this area. One of it is auto remediation. If someone in this room believes that humans should be running or executing playbooks, I disagree. If you can fix an issue with the playbook, that should be automated. Make sure you build a framework which is extensible and scalable. We built something internally. It's called Halo. It can do a bunch of things. It's also smart enough to, as an example, if one of the remediations is taking a host out of rotation, it ensures that it doesn't take all the hosts out of rotation. There's a limit on the number of hosts it can take out of rotation. We also have a product health dashboard that's pretty much up on TV screens all throughout Yahoo. In fact, it's called Panorama. It's been used by 5 business units across 70 different properties. It also lets you troubleshoot production issues. So if you have multiple data centers like us, it's easy for someone to quickly drill down to where the issue is. You can potentially isolate that to one data center. And finally, directed alerting. I know you probably saw this in a few slides. We only send alerts to teams who can actually fix them. So we don't, at least, I'm not a huge fan of a knock. Again, as I mentioned earlier, that feedback of your applications running in production should go back to the people who have actually written the software. And I fundamentally believe in that. So that's what we mean by directed alerting. All right, so if I were to sum everything up, enabling, make sure you are enabling a culture of ownership and excellence, engineer agile and automated processes, develop reusable and self-serve tools to kick ass at delivery, prevention, and repair. It's sort of a framework we use to look at things. I know this was sort of high level, but Gopal, trust me, has a more interesting talk, and he'll get into specifics of resilience. Before I go, I do want to sort of conclude my talk by saying, every day you come to work, evaluate your choices, right? You have your decisions, your choices, your efforts, your interactions all lead to sort of, paving the road towards your DevOps transformation, DevOps or lean transformation. So it's really about the everyday choices you make. And again, as I mentioned, earlier during my talk, resilience is a critical component of launching products, and Gopal will speak about it in detail. All right, off to Gopal. Oh yeah, King Hill.
Thanks, Kishore. As we have seen in previous slides that Yahoo undergoes many changes every day. The infrastructure is going through so many changes. There are multiple teams making multiple releases every day. These changes could be defect fixes, new features, or technology upgrades, or it could be any other variety of change. And these changes has possibility to bring down the system. It could affect the system in a bad manner. So, and not only the internal changes, there are external factors as well, like DDoS attacks or a traffic spike or a fiber cut happening somewhere under the sea. Those changes or factors could also affect the system very badly. So we need resiliency in our system, and the resiliency needs to be in the system right from the inception. So I'm going to cover the resiliency mainly for yahoo.com, which is our homepage, and media sites. This is one among the top 3 destinations on internet. The page is personalized. The page is composed of multiple modules, and normally each module is powered by separate service on the server side. You will notice that this page has so many components, and on the back-end side, we have hundreds of components working together to serve this page. And there are so many changes going on in the system at any given point of time. In spite of all this, we have 5 nines of availability on this page and other media sites. So having high availability in such a complex system is really a big challenge. Let's understand why availability is a challenge in such a complex environment. So whenever we build a system, we try to pull together the components which are the best components for the use case we are trying to solve. And when they are best components, their individual availability is also very high. So in this example, we see that the availability for each component is 3 nines, which is pretty good. But you will notice that the combined availability of the system is 99.5%, which is just 2 nines. The downtime for this system will be 1 day and 19 hours per day. When you are operating at a user base of 1 billion, this is not acceptable. So the point we are trying to make here is that in a complex system, as we keep on adding more and more components, the overall availability of the system keeps going down. Now you can imagine that a big system in which there is a continuous evolution going on. The new features are coming up every day, and we are adding more components, and the availability is going down every day. One more thing to notice here. The availability of the weakest component here is 99.9%, which is pretty good. But the availability of total system is much lower, 99.5%. What this is saying? This is saying that the combined system is weaker than the weakest subsystem. This means if we have a build system with the best of the best components, still we are not getting the kind of resiliency we want in the system. So given that availability is a challenge, how do we ensure that at Yahoo we have a good availability for our products? So I'm going to cover the resiliency for our serving stack, which is on the server side. Client-side resiliency is also a fascinating topic, and that deserves a separate talk. So in our server side, we have 4 layers of resiliency. As you can see here, speculative retry, per module fallback, full page failsafe, and fail well be write back page. So let's start with speculative retry. Now in a complex system, the tail end latency, the latency after the 95th percentile and the intermittent failures makes the system reliability very low. If you add the tail end latency of all of these components together, the overall system at 95th percentile is kind of a chaos. There is nothing guaranteed, and the last 5% of requests, there is no guarantee that they will be done right within the time budget you have allotted. Now we have when we have a 1 billion users, the last 5% of request is still a pretty large volume. We cannot afford to ignore them. So we need a resiliency such as speculative retry to take care of the tail end latency. So how this works? Normally, from 0th percentile to 95th percentile, the system behavior is pretty predictable. All the requests going, they come back in time, and we are all happy. The requests are being served very nicely. But beyond 95th percentile, when a request takes much more time than what it should have taken, we have a threshold. We call it as a speculative retry trigger time. At that point, we trigger a new request. We call it as a speculative retry. So now we have two requests going in parallel. One is the original request, and the other is speculative retry. Any one request which comes back first, we pick up that response, and we cancel the other request. Now the possibility of retry request succeeding is very high because there is a high probability that it will fall into the first 95th percentile range, and we know that we have a predictable behavior in first 95th percentile range. So I would like to also mention about the backup request. Some companies implement backup requests, or they call it cancellation. What they do in this case is that for every request, they will fire two requests always. Whichever comes back first, they will pick up the response from that and cancel the other one. This approach is also good, and it helps to solve the same problem, but we require double the amount of resources. We need double the servers, and we need double the network resources. On the other hand, on speculative retry, we make a request only on demand, which means the additional resources required may be 5% or 10%, depending on when we trigger the speculative retry. So few more considerations for speculative retry. This is useful only for idempotent request. This means the system behavior should be same if one request is made or multiple requests are made. We need to define a max retry rate because we have not provisioned enough capacity in the downstream to handle large number of requests. So if there is a possibility that we may start firing large number of retries. So if there is a max retry rate, then that parameter is going to help limit the number of retries. We should also prefer the retry on a new connection. The reason is, if you reuse the same connection on which original request was made, there is high chances that the retry will also follow the same network route and end up on the same servers where original request is stuck. And you don't want your retry request to go through the same set of situation or the problems that original request is facing. So using a new connection helps us to avoid the same problem that original request is going through. One more point is tracking of retry request. So if you are using request IDs to track the request and put some entries into the log files, then make sure that the retry request has a different request ID than the original. Often we miss this, and when we look into the logs, we see that the retry logs and the original logs, they are all same IDs and difficult to find out what is doing what. And finally, use the feature flags because there may be a time when you want to turn on or turn off the feature. So these are the results we have seen with speculative retry. So we tuned our most critical components on the page, and we see that we are required to do a 4 to 6% of retries, and with this we are able to limit the tail end latency to a great extent. Also, the intermittent failures are handled in a much better way. And with this, it also helps us improve our fallback rate, which I will discuss in the next slide. So as we discussed, that our page is composed of multiple modules, and each module is personalized content. And there may be a time when this personalized content being coming from a service in the backend is down. It may be down for a prolonged time, like 30 minutes or 1 hour. Now, we cannot afford to remove this module from the page when such a situation happens. And because it is personalized content, the module's data is also not cached. So what we do is we take a middle ground. We say that, okay, let's cache the non-personalized content from this module and keep that cache ready when it is needed. I'll go back to that slide later. So here are how it works. We have a set of offline servers which caches the non-personalized content, and that cache is always available on the front-end servers. So when there is a need for this cache, the cache data is available right on the front-end server. We put it onto the page and serve to the user. Most likely the user will not even notice what happened, that they have been served fallback content, because the look and feel is exactly same. The content is not personalized, but it is most popular at that point of time, and mostly the user will not mind having such content. So we need to be careful that such an approach may not be always usable. For example, if there is a real-time data you are showing in a module, then you can't cache real-time data like sports scores. There may be personal info like stock tickers or portfolios. There also we need to be careful. These are results for per module fallback. We try to keep it very low. In this case, it is like 0.5% or lower. If it goes high, there is immediately action taken to limit the fallback rate. But it helps us in preventing a bad experience going to user. We know that it is a slightly degraded experience, but it is still a better trade-off than removing the module altogether. Okay, so this brings us to our third layer of resiliency. We call it full page failsafe. This page is served when we are not able to prepare a regular page from our data centers. Usually this kind of situation will happen and it will be local to one data center. So in that case, our load balancers are smart. They will be able to shift the traffic to the next data center and users will not be affected at all, which is good. But sometimes there are bad days and we cannot serve the page from any of the data center. And what happens in this case, what do users do? They are trying to reach our sites, the browser is not rendering the page, and when users don't see the page on the browser, what do? They start hitting the refresh button. So on one hand, we have a big problem where we are not able to serve the pages. On the other hand, on top of that, we have a 2x more traffic because of the refresh buttons. So is this a worse situation? The worst is still much more than this. Imagine this thing happens when you have a peak traffic of the day. So the problem compounds. And still this is not worst. Imagine this happens when you have the peak traffic of all time. This is the worst thing happening. And somebody may say that, okay, such a worst situation is going to happen maybe once in a while, once in few years. Why to care for this? We can probably ignore such case. But I don't think so. Because when the probability of such an event happening is very low, but remember, when such an event happens, the probability of surviving is also very, very low. Here is reason why. Let's assume such an event happens now. So let's try to imagine what happens. The traffic starts to rise in our data center. The ramp is pretty steep. Buzzers are going off. Teams are coming together to start analyzing what's going on. Very soon 10 minutes passes and the traffic has reached all-time high. The system is under tremendous overload. All the components in the system are under stress. One of the components starts shaking and immediately fails. That failure leads to one more failure, and that failure leads to another failure. Very soon you have failure events cascading through the system. The system starts to collapse. When you have a system which is so complex and such a tremendous load is going on the system, even a slight imbalance in the system is going to bring it down. Now imagine you have 1 billion users on top of that. These 1 billion users are trying to hit your site because there is an important event happening in the world that makes them to come to Yahoo because they trust us and rely on us. They want to find out what's going on in their world. There is something important happening. So we have a peak traffic and we are not able to serve them the pages. For us, this is a very pretty bad situation. It's really embarrassing, and we need to be prepared for this. And therefore, we don't ignore even this rarest of the rare event, and we remain prepared for that. And how do we solve this? The solution is pretty simple. And it has to be a simple solution because we believe that anything complex in this situation will probably fail. So we have a crawler in our data center which crawls our own sites and pushes the data to AWS. We have a fail-safe stack on AWS. So whenever needed, traffic gets shifted to AWS. And you will notice that there is no single point of failure between two stacks. So high probability that fail-safe stack will work when it is needed. One more important thing, we push the data to AWS in gzip compressed form. So when it needs to be served, we don't need to do even compression. The page that we are going to serve as a result of this cache, the full page, is pretty simple. It is a logout experience. No advertisements on the page. The interactions are minimum. The JavaScript is minimum. The goal is to simplify it to such a level that the probability of it failing is very, very low. And we use autoscale on AWS, so this helps us to start scaling up whenever needed. Because when unprecedented level of traffic comes, you don't know what capacity will be enough. So autoscaling is very useful here, and it helps us to make the solution cost effective. So this is our solution or the resiliency layer 3. This is full page failsafe. And we are now coming to our last layer. Sorry, I was hitting the wrong button. Yeah, fail well page. So this is our layer 4 resiliency. Like Twitter, we have our own fail well page. This is last resort. When everything fails, we serve this page. And we would never like to serve this page, but we need to be prepared for this as well. Why? Because we think that giving a gateway timeout or internal server error to a user is not good. We need to give an honest answer to our users that, hey, we know that you need our services, but we have a problem on our side. We are working very hard to solve it, and we will be back soon. There is one more use case where this page is useful. There are a lot of users, they come to yahoo.com to see if their internet is working. So when we have a problem and if they try to check, we will give them server timeout. They may not understand it and they may think internet is broken. So we give this page and tell them that, hey, your internet is working fine and good. We have a small problem on Yahoo side and we will fix it soon. So that brings to my concluding slide. What we have discussed so far here is that in order to bring resiliency in a system, we need to analyze all the failure types, the entire range of failure types. We need to understand their rate. We need to understand their impact level. Put all this information together and come out with a holistic plan. What I mean is try to develop safety nets. So safety nets such that any kind of error happening, you will be able to catch them and handle them. With this, your solutions will be cost effective and efficient. Also try to bring a culture of resilience in the teams. Like at Yahoo, when a product manager gives requirements, he will tell us, these are your requirements in normal conditions. These are your requirements in per module fallback. These are your requirements when full page failsafe happens. So right from the product inception, we have taken resilience into account. When such a requirement goes to engineering team, design team, or production engineering team, they all pay attention to these requirements and do the right job what needs to be done. And what happens is a resilient system comes out of this process. Last, I will say that use lots of fire drills. Because after implementing and putting efforts in bringing resiliency, hoping that resiliency will work when it is needed is a myth. You need to have fire drills all the time to keep checking that your resiliency measures are ready and act when they are needed. So keep fire drills and testing as regular as possible, make it automated if possible. With this, I would like to conclude our talk. Thank you everybody for listening to us. We'll be available for any questions if you have after this session. And thanks, everybody.